So we need to talk through a few things about blood pressure, just to kind of keep us all on the same sort. So we have a few things that we want to remember. Flow, flow equals F. There's another term, change in pressure. And another term, R equals resistance. If we look at it from the flow equals the change in pressure divided by resistance, we're starting to look at it from a different way now, because we can look at it from the change in pressure can be related to our mean arterial pressure. So it is essentially this term right here is our map, mean arterial pressure. And then we can look at it from a different aspect. The mean arterial pressure equals the cardiac output times total peripheral resistance, the TPR. So this ends up being a really important part, because our mean arterial pressure looks something like this. We showed 120 millimeters to 80 millimeters of mercury. This is time. And then at the aorta. And then our arterioles will just go to here. So right here at our aorta, during systole, it ejects at 120 millimeters of mercury. It comes down to 80 millimeters of mercury. And this continues as we decrease our pressure as we enter into our arterioles and enter into the capillaries. And our mean arterial pressure just means, it's right down here. Mean arterial pressure is, it can be calculated a different way. It is mean arterial pressure, I believe. Try to get to the paper. Equals the diastolic pressure plus 1/3 systolic pressure minus diastolic pressure. So that's our mean arterial pressure related to our figure here. So if we looked at it from a normal conditions, we'd see MAP equals 80, that's our diastolic, plus 1/3, 120 minus 40, or 120 minus 80 equals 40. And this equals 93 millimeters of mercury. We need somewhere between 70 and 110 millimeters of mercury in order to keep our organs perfused with the proper amount of blood. So mean arterial pressure gets to be really interesting when we look at it from the aspect of hypertension. So for example, let's say someone had a blood pressure of 160 over 120. Our mean arterial pressure then is going to equal 120 plus 1/3, 40. And because 120 or 160 minus 140 is 4, or 120 equals 40, we get a mean arterial pressure of 133 millimeters of mercury. This is enough to blow the vein or the arteries apart. So this is why hypertension is so important to get dealt with. That way we can keep our mean arterial pressure within the correct range, our organs are getting the proper amount of blood, and everything is working just fine.